Right, this is a bit of a weird one. Right, so we've got our sequence, which is A, B, C, D, and it's geometric, which means to go from term to term, we have to multiply by some number that we don't know. Yeah? So A is the first term. B... B is A multiplied by OR. C is A multiplied by OR, so it's A multiplied by OR squared. And then D is A multiplied by OR 3 times, so it's A OR cubed. Yeah? Okay, this thing here then is A squared minus B squared minus C squared plus D squared. And we're trying to prove that that's greater than or equal to 0. So essentially greater than or equal to 0 means we're trying to prove that it's positive. Generally, when we're trying to prove that things are positive, we're looking for things to be squared. Now, I appreciate here everything is squared, but also there's minuses. Ugh. So anyway, so it's A squared minus A squared or squared minus A squared or to the 4 plus A squared or to the 6. Now, I can take A squared out as a common factor, which is good because that is a square. And squares are always positive. So that's potentially good. It leaves us with 1 minus OR squared minus OR to the 4 plus OR to the 6. I mean, is that enough? I think it might be. Do I go one more? I mean, they're all positive. I want to do one more factorisey thing. Hang on. So I'm just going to come up here. So it's A squared times 1 minus, right? And then out of these, I'm going to factorise out OR squared. So if I take out minus OR squared, it leaves me with OR squared plus OR to the 4 minus OR... No. Sorry, I took out OR squared, so it doesn't leave me with that. So if I take OR squared, minus OR squared out of that, I'm left with 1. Sorry. If I take minus OR squared out of that, I have plus OR squared. And if I take minus OR squared out of that, I have minus OR to the 4. Right, and I'm trying to prove that that's positive. Now, this feels better. Okay, so if we look at this, I think because OR to the 4 is always going to be bigger than OR squared, I think that that bracket's always going to be negative. Let's do an example. So if we let OR equal, let's let OR equal something negative, so like minus 4. This would be 1 plus minus 4 squared minus 4 to the power of 4, which would be 1 plus 16 minus 256. So that is 17 minus 256, which is minus 239. Okay, and I think no matter what you put in there, that bracket is always going to be negative. Yeah, but then you're multiplying that bracket by a minus OR squared. We can be positive that the OR squared itself is plus. So essentially what we're doing here in like this bit is we're multiplying a minus by a minus, which is always going to be a plus. Then we're just adding the 1 that's here. That's still going to be positive. So the bracket is always positive. And then we're multiplying the whole thing by A squared, which is also positive. So I think we can be fairly sure that this is true. I can't see a way to do it any cleaner than that. I've done it a few times. And I think that's the cleanest way. I'm trying to get all the... It's fine. Leave it. That's the cleanest way I can figure it out. So r to the 4 is always going to be bigger than r squared, which means that purple bracket there that's highlighted is always going to be negative. You're then multiplying that negative by this negative, which is always going to be positive, and then you're just adding a 1. So that bracket from here to here is always going to be positive, and then you're multiplying it by an a squared, which is also always going to be positive. So overall the whole thing is positive, which means the statement is true, and we've proved it. I can't find a solution, so I don't know if they've managed to do it any prettier than that, but it's proved, so I would be happy with that.